Hello students. In the last two videos we taught you how to use the difference of two squares to expand a binomial times a binomial, and then we taught you how to work in reverse and factorize it once you have a difference of two squares. Okay, we're going to look at a different special product in this video and the next one, and we're going to start by expanding what are called perfect squares. So have a look at this expression just here. It's called a perfect square because instead of multiplying a plus b times a plus b, we can just say, well, that's really a plus b all squared. In other words, the two factors or the two expressions that we're multiplying together are the same thing. Let's go ahead and expand it using the rectangle method and see what we come up with. So a plus b times a plus b is a plus b in brackets all squared equals, well, a times a is a squared plus ab plus b times a, which we also write as ab, plus b squared. And the middle two terms we can add because they're like terms, and we end up with a squared plus 2 times a times b plus b squared. And that's called expanding a perfect square. So it turns out that if you learn this particular pattern, and it's certainly worth your trouble to do so, anytime we have a perfect square, so a binomial like a plus b, all squared, it'll just be the square of the first term, which is a squared, the square of the last term, which is b squared, and then twice the first term times the second term. So let's go ahead and do that on a few questions. Okay, in fact, before we do that, we're just going to talk about a bit more about perfect squares. Okay, so what I have here is what I just wrote on the previous page. A plus b all squared can be expanded to a squared plus 2ab plus b squared. Well, it turns out that it also works similarly for subtraction. A minus b all squared gives us a squared minus 2ab plus b squared. Now the reason that's a plus on the end, of course, is this is like plus negative, so we got negative times a negative gives us a positive. So we have two rules. We have one for a plus b all squared, another one for a minus b all squared. Well, it turns out that the only difference between the two is if that's subtract, that's a subtract. That stays as a plus. So we can write those two rules as a single rule. A plus or minus b all squared equals a squared plus or minus 2ab plus b squared. In other words, if it's a plus there, it's a plus there. If it's a subtract there, it's a subtract there. Okay, let's go ahead and apply that to a couple of problems. So we're going to expand each of the following expressions using the perfect square rule, which is written up there just to remind you. And this is, again, one that's worth memorizing because we use it a lot in both this section and also in subsequent study of mathematics. Okay, I'm going to do two of these, and you're going to do two of these. I'm going to do one of them by showing some setting out, and the second one, I'm going to do it the setting out in my head and just write the answer. So let's do this one the longer way by doing the middle step and then the final step. So that's of the form a plus b all squared. So that's a, and that's b. And I know that I can write it as a squared plus 2ab plus b squared. Well, a squared in this case is just p squared plus 2, and I'm going to use the dot for multiply, 2 times p times 4, so that's 2ab, plus b squared, well, b squared is 4 squared or 16. And I'll put the second part of it down there. And then finally, 2 times p times 4, we'll multiply the 2 by the 4, which is 8 times p. So plus 8p plus 16. Now, how could I have done that in one step? Well, here's how I would have done this in one step. I would have said square a, so a squared is p squared. Then I would have said 2 times a times b. Well, often I go 2 times b first, because it's a number times a number, which is 8 times p is 8p, plus 4 squared is 16. So let me apply that to this question just here. I'm going to do this in one step. So first I need a squared. Well, 3h all squared. 3 squared is 9, so that's 9h squared. Because that's a subtract, that's a subtract. Now I need 2 times a times b. 2 times that times that. Well, it's quickest for me anyhow to go 2 times 4 is 8. 8 times 3 is 24. So it's 24h. And plus b squared, well, 4 squared is 16. And there's the answer in a single step. Okay, go ahead and try the other two on your own, please. So you can either do it in 2 steps or you can do it in 1 step, your choice. Okay, let's see how you went on this, students. So I'm going to do this one the short way and that one the short way. So I've got the form a plus b all squared, so I know that I can apply this pattern to it up here. So that equals a squared, so 2f all squared is 4f squared, because that's a plus, that's a plus. Now I need 2 times a times b. Well, 2 times 5 is 10, times 2 is 20, so that's plus 20f, plus b squared. Well, 5 squared is 25, and there's that expanded in 1 step. Okay, doing the second one, 2k times 2k is 4k squared. That's minus 2 times 5 is 10, times 2 is 20, so minus 20k, and plus 5 times 5 is 25, and there's the answer expanded in 1 step. Now in the next video, we're going to have to go back from this form back to that. So first we have to figure out, is this a perfect square? And if it is, how do we get from that form back to that form? So you might want to stop and have a bit of a look right now and see if you could figure out what we might be doing in the next video to get from this back to that. Okay, we'll see you in the next video.